LangGraph implements a hierarchical state management system through nested graph structures, where subgraphs encapsulate isolated state schemas while parent graphs orchestrate high-level workflows. This modular architecture enables precise state transformations between layers, with streaming capabilities that surface real-time updates from both parent and nested execution contexts. We're about to examine how a parent graph invokes a subgraph through explicit state mapping, where the subgraph's isolated subgraph state schema gets transformed into the parent state schema during execution. The implementation will demonstrate streaming outputs from nested graph structures while maintaining clean separation of concerns between graph layers. From typing extensions, import type dict. From LangGraph, graph state import state graph start. Hash define subgraph. Class subgraph state type dict. Hash note that none of these keys are shared with the parent graph state. Bar str. Baz str. Def subgraph node 1 state. Subgraph state. Return Baz. Def subgraph node 2 state. Subgraph state. Return bar. State bar plus state Baz. Subgraph builder equals state graph subgraph state. Subgraph builder. Add node subgraph node 1. Subgraph builder. Add node subgraph node 2. Subgraph builder. Add edge start. Subgraph node 1. Subgraph builder. Add edge subgraph node 1. Subgraph node 2. Subgraph equals subgraph builder. Compile. Hash define parent graph. Class parent state type dict. Foo str. Def node 1 state. Parent state. Return foo. Height plus state foo. Def node 2 state. Parent state. Hash transform the state to the subgraph state. Response equals subgraph, invoke bar, state foo. Hash transform response back to the parent state. Return foo, response bar. Builder, state graph parent state. Builder add node 1. Builder add node 2. Builder add edge start, node 1. Builder add edge node 1, node 2. Graph equals builder compile. For chunk in graph, stream foo. Foo, subgraphs equals true. Print chunk. This code demonstrates how to stream outputs from nested subgraphs while managing state transformations between parent and child graphs. The pattern shows a parent graph invoking a subgraph with completely different state schemas, requiring explicit state transformation at the boundary. The parent graph maintains a simple foo state key, while the subgraph uses separate bar and baz keys. When node 2 in the parent graph invokes the subgraph, it first transforms the parent state by mapping foo to bar, then transforms the subgraph's output back to the parent schema by taking bar from the subgraph's result. This isolation allows subgraphs to maintain their own state structure while still integrating with parent workflows. The streaming output reveals how LangGraph handles nested execution, showing updates from both parent nodes and subgraph nodes when subgraphs equals true is specified. Each chunk in the stream includes a tuple identifying the execution path and the state updates, demonstrating the hierarchical relationship between parent and child graphs. This approach enables modular graph design, where subgraphs can be developed independently as long as their input-output transformations are properly handled at integration points. Let's break it down. From typing extensions, import type dict. Imports typed dict from typing extensions for creating dictionary-like structures with type annotations. From LangGraph, graph state import state graph start. Imports state graph and start from the LangGraph, graph state module. State graph is a class for creating stateful graph structures, and start is a constant representing the initial node in a graph workflow. Class subgraph state type dict defines a subgraph state class
that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys and values. This establishes a typed data structure for managing state within subgraphs, ensuring type safety and clarity when working with nested graph components.
Def subgraph node 1 state. Subgraph state.
Defines a function named subgraph node 1 that takes a single parameter state of type subgraph state. The function signature indicates this is likely a node within a LangGraph subgraph, designed to process or transform the provided state object.
Return baz. Baz.
Returns a dictionary with a single key baz, mapped to the string value baz.
Def subgraph node 2 state. Subgraph state.
Defines a function named subgraph node 2 that accepts a single parameter state of type subgraph state. This establishes a node function within a LangGraph subgraph, where the function will process the provided state object when executed. The function signature indicates it's designed to operate on the state data flowing through the graph, though the specific operations aren't visible in this segment.
Return bar. State bar plus state baz.
Returns a dictionary with a single key bar, whose value is the sum of the bar and baz values from the current state.
Subgraph builder equals state graph subgraph state.
Creates a state graph instance named subgraph builder that operates on the subgraph state class. This initializes a graph structure that will manage state transitions and workflows using the specified state type.
Subgraph builder. Add node subgraph node 1.
Adds a node identified by subgraph node 1 to the graph being constructed by subgraph builder. This operation registers the node within the builder's internal representation, making it available for subsequent graph operations like edge creation or execution.
Subgraph builder. Add node subgraph node 2.
Adds subgraph node 2 to the graph being constructed by the subgraph builder. This operation registers the node within the subgraph, making it available for connections and execution in the graph's workflow.
Subgraph builder. Add edge start. Subgraph node 1.
Adds a directed edge from the start node to a node named subgraph node 1 in the subgraph being constructed by the subgraph builder. This establishes a connection where execution can flow from the graph's entry point to the specified node.
Subgraph builder. Add edge subgraph node 1. Subgraph node 2.
Adds a directed edge from node subgraph node 1 to node subgraph node 2 in the subgraph being constructed by the builder. This establishes a dependency where subgraph node 2 will execute after subgraph node 1 in the workflow.
Subgraph equals subgraph builder. Compile.
Calls the compile method on the subgraph builder object, which processes the subgraph configuration and returns a compiled subgraph ready for execution. The resulting compiled subgraph is assigned to the variable subgraph.
Class parent state type dict.
Defines a parent state class that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a type-safe container for state data, where each field's type can be explicitly declared when the class is fully defined. The line itself only declares the class name and inheritance, without specifying any fields yet.
Def node 1 state. Parent state.
Defines a function named node1 that accepts a single parameter, state, with type annotation parent state. The function signature indicates this is likely a node in a LangGraph workflow that processes or transforms the graph state, but the implementation details aren't visible in this segment.
Return foo, height plus state foo.
Returns a dictionary with a key, foo, whose value is the string high, concatenated with the current value of state, foo. This operation creates a new dictionary that preserves the existing state while modifying only the foo field by prepending high to its current value.
Def node to state, parent state. Hash transform the state to the subgraph state.
Defines a function named node2 that accepts a single parameter, state, of type parent state. The comment indicates this function's purpose is to transform the incoming state into a format suitable for a subgraph, though the actual transformation logic isn't shown in this segment. The function signature suggests it's part of a graph-based processing pipeline where state objects are passed between nodes.
Response equals subgraph, invoke bar, state foo.
Invokes the subgraph with a dictionary input containing a single key, bar, mapped to the value of state foo. The invoke method triggers execution of the subgraph, passing the constructed input dictionary as its argument. The result of this invocation is assigned to the variable response.
Return foo, response bar.
Returns a dictionary with a single key, foo, mapped to the value of bar from the response dictionary.
Builder, state graph parent state.
Creates a state graph instance using parent state as the state type. This initializes a graph structure where nodes will operate on and modify state objects of type parent state. The builder variable now holds this graph instance, ready for adding nodes and defining edges.
Builder add node, node 1.
Adds a node named node1 to the graph builder, associating it with the node1 function or object. This registers the node in the graph structure, making it available for connections and execution within the workflow. The first parameter is the node's identifier, and the second is the implementation to be invoked when the node executes.
Builder add node, node 2.
Adds a node named node2 to the graph builder, associating it with the node2 function or object. This registers the node in the graph structure, making it available for connections and execution within the workflow. The node will be identifiable by the key node2 in the graph's node collection.
Builder at edge start, node 1.
Adds a directed edge from the start node to node 1 in the graph being constructed by the builder. This establishes a connection where execution will flow from the graph's entry point to the specified node.
Builder add edge node 1, node 2.
Adds a directed edge from node 1 to node 2 in the graph being constructed by the builder. This establishes a dependency where node 2 will execute after node 1 completes, defining the control flow between these two nodes in the workflow.
Graph equals builder compile.
Compiles the graph constructed by the builder into an executable graph object. The compile method takes the graph definition created through the builder and produces a runnable graph instance that can be executed or streamed. This is the final step in graph construction before execution.
For chunk in graph, stream foo. Foo, subgraphs equals true.
Iterates over a stream of chunks from the graph's stream method, passing an input dictionary, foo, and enabling subgraph output streaming via the subgraph's equals true parameter. Each iteration processes a chunk of streaming data, which may include outputs from both the main graph and any nested subgraphs.
Print chunk.
Prints the value of the variable chunk to the standard output. This is a simple debugging or logging statement that displays the current content of chunk during execution. LangGraph's hierarchical state management shines through this nested graph structure, where subgraphs maintain isolated state schemas while parent graphs orchestrate the high-level workflow. The key insight is how explicit state transformations at the boundary between parent and subgraph enable clean separation of concerns. The parent graph's node 2 handles this transformation by mapping the parent's foo state to the subgraph's bar input, then converting the subgraph's output back to the parent schema. This modular design allows subgraphs to be developed independently as long as their input-output transformations are properly handled at integration points. The streaming capability with subgraphs equals true reveals the hierarchical relationship during execution, showing updates from both parent nodes and subgraph nodes in real time. Each chunk in the stream includes execution path information and state updates, demonstrating how LangGraph maintains clean state isolation while enabling nested execution. This pattern of state transformation and streaming output creates a powerful abstraction for building complex workflows from simpler, reusable components.
The subgraph stitches bar to baz, but the parent graph unravels foo into silence. Where did the thread go?